Hi everyone, welcome back. In this video, we are going to discuss most asked interview questions and answers on Spring Framework for beginners and experienced developers. Let's begin with what is the Spring Framework and why is it widely used in enterprise applications? The Spring Framework is a comprehensive framework for building Java applications with a strong focus on flexibility, maintainability, and testability. At its core, Spring helps developers manage application components and their dependencies in a clean and structured way. Instead of tightly coupling classes together, Spring promotes loose coupling through dependency injection. Spring became popular in enterprise applications because it simplifies complex problems that traditionally existed in Java development. It removes boilerplate code, improves configuration management, and provides consistent patterns across different application layers. Another key reason for Spring's adoption is its modular design. Developers can use only the parts they need, such as core container, data access, web or security modules. This avoids unnecessary complexity. Spring also integrates well with other technologies. It does not force developers to use a single approach or vendor. This flexibility makes Spring suitable for large-scale, long-lived enterprise systems. In interviews, experienced developers are expected to explain that Spring is not just a framework but an ecosystem. Interviewers look for understanding of how Spring improves design quality, reduces coupling, and supports scalable enterprise architectures. Next question. Explain dependency injection and inversion of control in Spring. Dependency injection and inversion of control are the foundation of the Spring framework. Inversion of control means that the responsibility of creating and managing objects is moved from the application code to the Spring container. Instead of objects creating their own dependencies, Spring provides them from outside. Dependency injection is the mechanism used to achieve this. Dependencies are injected into a class through constructors, setters, or fields. This removes tight coupling between components. Because classes do not control how dependencies are created, they become easier to test. Mock objects can be injected during testing without changing application code. Dependency injection also improves maintainability. When requirements change, implementations can be swapped without modifying dependent classes. This supports clean architecture and long-term evolution. In interviews, experienced developers are expected to go beyond definitions. Interviewers want to hear how dependency injection improves design, enables unit testing, and reduces hidden dependencies in large codebases. Next question. What is the Spring IOC container and how does it work internally? The Spring IOC container is responsible for managing application objects known as beans. It reads configuration metadata, creates beans, injects dependencies, and manages their lifecycle. Configuration can be provided through annotations, Java configuration classes, or XML. Internally, the container follows a well-defined lifecycle. It first scans and loads bean definitions, then it creates bean instances, resolves dependencies, and applies configuration such as initialization callbacks. The container also manages cross-cutting concerns like proxy creation for features such as transactions and security. This is done transparently without modifying business logic. Bean scopes and lifecycle callbacks are handled by the container, ensuring consistent behavior across the application. Developers focus on business logic rather than object management. In interviews, experienced developers are expected to explain that the IOC container is not just a factory, it is a sophisticated runtime environment that manages object creation, wiring, lifecycle, and integration with other Spring features. Next, what are Spring Beans and how are they managed by the container? Spring Beans are objects that are created, configured, and managed by the Spring IOC container. A bean is typically a plain Java class with no dependency on Spring APIs. Spring manages how and when the bean is created, how dependencies are injected, and how it is destroyed. Beans are defined using configuration metadata. This metadata tells the container what class to instantiate, how to configure it, and which dependencies to inject. The container ensures that beans follow a life cycle. It handles initialization callbacks after dependencies are set and destruction callbacks before shutdown. Spring also supports different bean scopes, allowing developers to control how often a bean is created. This flexibility is important for managing shared or stateful components. In interviews, experienced developers are expected to explain that beans are not special classes. They become powerful because the container manages them consistently and applies cross-cutting features transparently. Next question. Explain the different bean scopes available in the Spring framework. Bean scope defines how many instances of a bean Spring creates and how long those instances live. The default scope in Spring is singleton. In this scope, only one instance of the bean is created per Spring container and shared across the entire application. This scope is ideal for stateless services and is used most commonly in enterprise applications. The prototype scope creates a new bean instance every time the bean is requested. This is useful for stateful or short-lived objects, but Spring does not manage the full life cycle of prototype beans after creation. Spring also provides WebAware scopes for web applications. The request scope creates one bean instance per HTTP request, while the session scope creates one instance per user session. These scopes are useful for handling user-specific or request-specific data. The application scope creates a single bean instance for the entire web application. It is shared across all users and sessions, similar to a servlet context-level singleton. Spring also supports WebSocket scope, which ties the bean lifecycle to a WebSocket session. This is useful in real-time applications such as chat systems or live dashboards. In interviews, experienced developers are expected to explain all these scopes clearly and know when to use them. Incorrect scope selection often leads to concurrency issues, memory leaks, or incorrect application behavior. Next question. What are the different ways to configure Spring applications? Spring provides multiple ways to configure applications, allowing flexibility based on project needs. The earliest approach is XML-based configuration. In this approach, all beans and dependencies are defined using XML files. While it provides clear separation between configuration and code, it becomes verbose and difficult to maintain in large applications. Annotation-based configuration is more popular today. Developers use annotations directly on classes to define beans and dependencies. This approach reduces boilerplate and improves readability. Java-based configuration uses configuration classes to define beans using methods. It provides type safety, refactoring support, and better tooling support compared to XML. In modern enterprise applications, Java-based configuration combined with annotations is the preferred approach. XML is still used occasionally for legacy systems or special cases. In interviews, experienced developers are expected to explain why configuration styles evolved over time and how modern Spring applications favor readability, maintainability, and compile time safety over verbose configuration. Next question. What is @configuration and how is it different from a normal Java class? @configuration is a special annotation used to define Spring configuration classes. A class annotated with @configuration tells Spring that it contains bean definitions. These definitions are typically provided using methods annotated with @bean. The key difference between @configuration and a normal Java class is that Spring enhances configuration classes at runtime. This enhancement ensures that each @bean method returns a singleton instance by default. Without @configuration, calling a @bean method directly could create a new instance each time. With @configuration, Spring intercepts method calls and ensures consistent bean behavior. @configuration also allows beans to reference each other safely. Dependencies are resolved by the container, not by manual method calls. In interviews, experienced developers are expected to explain that a configuration is not just a marker. It plays a critical role in ensuring correct bean lifecycle management and dependency consistency across the application. Next question, explain the role of @bean and when you should use it. @bean is used to explicitly declare a Spring Bean inside a configuration class. It is typically used when you need to create beans from third-party libraries or when you want fine-grained control over bean creation. @signBean methods allow developers to customize object creation, initialization logic, and dependency wiring. This is useful when annotations cannot be added directly to a class. Unlike component scanning, @bean gives full control over how an object is instantiated. You can pass constructor arguments, configure properties, or apply conditional logic. @bean methods are managed by the Spring container, meaning lifecycle callbacks and dependency injection still apply. In interviews, experienced developers are expected to explain when to prefer @bean over component annotations and how it helps integrate external libraries cleanly into the Spring ecosystem. Next question, what is component scanning and how does Spring discover beans automatically? Component scanning is a mechanism that allows Spring to automatically discover and register beans. Spring scans specified packages and identifies classes annotated with component-related annotations. These classes are registered as beans in the application context. This approach removes the need to manually declare every bean. It simplifies configuration and improves development speed. Component scanning relies on clear package structure. Poor package organization can lead to missing beans or unintended registrations. It is important to limit scanning to relevant packages to avoid performance overhead and accidental bean conflicts. In interviews, experienced developers are expected to explain how component scanning works internally and why thoughtful package structure is critical for clean Spring applications. Next question, explain @component, @service, @repository, and @controller annotations. These annotations are specialized forms of component declaration in Spring. @component is a generic annotation used for any Spring managed component. It indicates that a class should be detected during component scanning. @service is used for service layer classes. It represents business logic and improves code readability. @repository is used for data access classes. It provides exception translation, converting low-level persistence exceptions into Spring's unified exception hierarchy. @controller is used in web applications to handle incoming HTTP requests and return responses. In interviews, experienced developers are expected to explain that these annotations are not just naming conventions. They communicate intent, enable additional framework behavior, and improve application structure and maintainability.